Okay then, this one, at first glance you think, hang on a minute, this isn't a quadratic because it's got power 4. But if you look at it, you can see that x to the 4 using properties of indices is just can be written as x squared squared minus 6x squared plus 8. So can you see that in form it's something squared minus 6 times something plus 8 in form. If you let y be the symbol for x squared, for example, you can clearly see it, that it would be y squared minus 6 times y plus 8. Now that's a quadratic. We could solve that for y and then we could just work out what x was, couldn't we? So why don't we do it that way? So y is equal to that. Hopefully this factorizes it because it looks fairly user-friendly. So y and y, that's the first line. Last term is 8, that would be 8 ones. There's symmetry, so I don't need to swap them around. Minus 8 times minus 1, 4 2's. Minus 4 times minus 2. So that's the last line, last term. Then the middle lines, lines 2 and lines 3, is the middle term. So y times this and y times that. And it needs to add up to minus 6. See it? So minus 4 can go in here, for instance, and minus 2 can go in there then. So that tells us that y minus 4 must equal 0, or y minus 2 equals 0, and this tells us y equals 4 and y equals 2, doesn't it? And that tells us that y, which we replaced instead of x squared equals 4 and x squared equals 2 are the two possible answers. Square root both sides then here, we get x equals plus or minus 2, don't we? And this one, x equals plus or minus root 2, which is okay to leave in third form. So there's 4 solutions for this, and we could tap them in to check that they were correct, of course, in the calculator here, and check all 4 of them.